searching the internet can reveal information a user would rather keep private. For instance, when someone looks up medical symptoms online, they could reveal their health conditions to Google, an online medical database like WebMD, and perhaps hundreds of these companies as advertisers and business partners. For decades, researchers have been crafting techniques that enable users to search for and retrieve information from a database privately, but these methods remain too slow to be effectively used in practice. MIT researchers have now developed a scheme for private information retrieval that is about 30 times faster than other comparable methods. Their technique enables a user to search an online database without revealing their query to the server. Moreover, it is driven by a simple algorithm that would be easier to implement than the more complicated approaches from previous work. Their technique could enable private communication by preventing a messaging app from knowing what users are saying or who they are talking to. It could also be used to fetch relevant online ads without advertising servers learning users' interest. The first schemes for private information retrieval were developed in the 1990s, partly by researchers at MIT. These techniques enable a user to communicate with a remote server that holds a database and read records from that database without the server knowing what the user is reading. To preserve privacy, these techniques force the server to touch every single item in the database, so it can't tell which entry a user is searching for. If one area is left untouched, the server would learn that the client is not interested in that item. But touching every item when there may be millions of database entries slows down the query process. To speed things up, the MIT researchers developed a protocol known as Simple PIR, in which the server performs much of the underlying cryptographic work in advance before a client even sends a query. This pre-processing step produces a data structure that holds compressed information about the database contents and which the client downloads before sending a query. In a sense, this data structure is like a hint for the client about what is in the database. The researcher says that once the client has this hint, it can make an unbounded number of queries, and these queries are going to be much smaller in both the size of the messages we are sending and the work that we need the server to do. This is what makes Simple PIR so much faster, but the hint can be relatively large in size. For example, to query a 1 gigabyte database, the client would need to download a 124 megabyte hint. This drives up communication costs, which could make the technique difficult to implement on real-world devices. To reduce the size of the hint, the researchers developed a second technique known as double PIR that basically involves running the Simple PIR scheme twice. This produces a much more compact hint that is fixed in size for any database. Using double PIR, the hint for a 1 gigabyte database would only be 16 megabytes. The researcher says that the double PIR scheme runs a little bit slower, but it will have much lower communication costs. For some applications, this is going to be a desirable trade-off. They tested the Simple PIR and double PIR schemes by applying them to a task in which a client seeks to audit a specific piece of information about a website to ensure that website is safe to visit. To preserve privacy, the client cannot reveal the website it is auditing. The researchers' fastest technique was able to successfully preserve privacy while running at about 10 gigabytes per second. Previous schemes could only achieve a throughput of about 300 megabytes per second. They show that their method approaches the theoretical speed limit for private information retrieval. It is nearly the fastest possible scheme one can build in which the server touches every record in the database. In addition, their method only requires a single server, making it much simpler than many top-performing techniques that require two separate servers with identical databases. Their method outperformed these more complex protocols. While the researchers have shown that they can make PIR schemes much faster, there is still work to do before they would be able to deploy their techniques in real-world scenarios. They would like to cut the communication costs of their schemes while still enabling them to achieve high speeds. In addition, they want to adapt their techniques to handle more complex queries such as general SQL queries and more demanding applications such as general Wikipedia search. And in the long run, they hope to develop better techniques that can preserve privacy without requiring a server to touch every database item.